Hi, I'm Sportster Paul. We're here with SolidWorks CAM, which is a free add-in 2018-1920. This is a 20. It's made by CAMWorks. Basic version's free in SolidWorks, but my problem with it, it doesn't have a perpetual license. So if you stop paying your SolidWorks maintenance, the free CAM program breaks. They do have an upgrade, I think $2,500, $3,000, professional CAMWorks Premium, which is the same as SolidWorks CAM Professional. And then CAMWorks has a 3D package called CAMWorks Mill. Meanwhile, I had a buddy, I've done these first impression, second, third impression with a silly little part I downloaded off the internet, having a lot of trouble because I'm not a machinist and I'm still learning and I haven't used CAM before. So a lot of misery here, a lot of suffering with software. But I had a buddy, Dave Rui, lives in Silicon Valley, total rock star. He's a mechanical engineer, industrial designer, a machinist. He does it all, right? He had a consulting business next to mine when I lived out there. So he made a part that he knows chokes CAM programs. He's a master CAM guy. He used to sell master CAM. And that's the premium. It's, I think, over $10,000 out of my price range as an intermittent user, a prototype guy. But it's got 80% of the market. So if anything will confuse a CAM program, and that's something that I'm struggling with this SolidWorks CAM. It all claims to be, well, it'll automatically do this and automatically do that. Well, I'm finding what it does automatically, you really got to touch up. Sometimes simple, just take it out. Other times, a big tear up. So let's see if we can come up here and start. I went Rui test part, read only. Open it read only, just to make sure. I went and got it off of his email when he sent it to me, because, okay, it's converted. He must be using an earlier version in 2020. So here's the part, and here's, it's, I think 3 inches by 4 inches. What is it? Solid body. Isn't it amazing? There we go. It's 3 by 4 and 1 inch tall. So much more reasonable than that first impression, second, third impression part that I was using, which is a ball nut. Shouldn't probably make it. Dave gave me some advice how to make that. And so we're going to have a fourth impression on that one and show you how Dave would make it, because he's a lot smarter than me. So here's why Dave knew. Now I understand why Dave figured this would screw things up. It's got a breakout here from this 1/4-20 tapped hole, and it's got another breakout here in these two bosses. But he did its thing. He let the SolidWorks do its thing. What do you do? Escape. And then here's where, here. It's interesting because his has all this, mine doesn't. All right. So when you go to SolidWorks, tools add-ins, turn on the CAM, you get these 3 tabs. This is the feature tree, shows all the features that this thing sees, that it automatically recognizes. I turned on this command manager here. It's a right click. So you can say extract machinable features, and I think that's what he did. I'll verify all this for the next, because there's going to be a couple of videos about this part, trust me. Then generate operation plan. That takes the features, like you've decided, well, that's a pocket, and that's a tapped hole. All of these things here, face. See, and you can see this thing's already screwing up. It's putting the face feature after the holes. So a center drill will crash. You'll rapid a center drill down into the stock because you haven't faced it off first. I don't know if Dave moved those around, or I didn't move it around. So these features come next. Then there's a tool crib. These are the black tools are the ones that use. Blue means it's not in use. And SolidWorks decided all that. So we're back in the features here, looking at all the features. You can see the tool paths. So let's get it so you can see it. Say simulate. Now, here's what's dangerous. If you say ignore collision and let it do its thing, it's pretty impressive. Got to cut these corners off. It does the perimeter, does this inside part. It all looks pretty cool. It's doing rest machining, very sophisticated, where it uses a 3/4 inch end mill, but then it can't get in the corners. Then it uses a 3/8 to get, the little bits that it couldn't get, but doesn't go over the whole pocket. It just does the ones that were left, rest machining. Then it does a finish around. Oh, so sophisticated. And you think, oh, well, this is cool. Look, it did it. This is what impressed Dave. But 2 problems. First, you got to know Oh, to show difference. This is how you see what's going on. Well, now, okay, I think he and I both didn't expect it to do this angle. That's called, you can do it, even though this is a 2.5 package, you can do it with, was it multiplane? I forget. So you can go and just raster across this and carve it down with a ball nose end mill. And that's another video. We'll show you that. So don't be worried that all this blue is left. This is the deal. See, when it's blue, it's uncut. When it's red, it's gouged. So this yellow one has got a little gouge here. And if you come in real close, oh, by the way, I found out you can switch the way the scroll wheel zooms to make it like TurboCAD. And that's options, view, I think. And it lets you change the way the mouse wheel. Now notice, it left this little blue thing, that's extra, and there's a little extra here, there's a little extra there. Then, oh, it's so heaven having the scroll wheel work the same in both. I use TurboCAD a bit, you know, for construction, stuff like that. It's a Boolean thing, it's not the best. And then it left a little bit here. See that little blue there? What's going on? What's that added to? So, that's a concern. And you say, oh, well, it's not much. It is, because the part's not to print. Okay, and the machinists I know, I got a lot of buddies who are machinists, they go nuts. It's not to print. It's gouged there. So, but the real problem, go here, you always want to pause on tool collision. Because this is what screwed me up once. It was out of order once again with the facing. So before it faced, it went to go do the center drills on some holes, except it rapids down right to the top of the part, but they're stock now because you haven't faced it off. Well, it all ends up looking great if you ignore collisions. But now that you turn collisions on, let's go to the beginning. It's doing its thing, it's doing its thing. Boom, first collision. And you'll see that's because this pocket is misdefined in the feature. When it automatically recognized it, it only recognized it starting up here. It doesn't seem to realize the pocket's supposed to be cut from top to bottom. Okay, so here I'll just start enter. Okay, all these tool crashes. Now it has some others with a drill, the rough mill, center drill. I think that's a little less problematic. I'm not sure. We'll have to go look. Oh yeah, because once again, it's order of operation. They're doing those two holes. Why they're doing them from above, I don't know. They could do all the holes from underneath. This is when computers do your thinking instead of your work. So that's what was going on there. All right. All right. And see, same thing, because the facing is in the wrong operation. And like I say, I don't know if Dave moved them around or what. I can't imagine he did, but okay. Okay. And see, there was the face, the big face thing that you saw fly by. So that's the first problem. Okay, so now we know we got this gouge here, we got a little extra material, something isn't right here. So in the feature, in the middle one, okay, I'm sorry, I said feature, but this is like it's so confused with these two tabs. The operations tab, not the tool, the middle tab. Okay, first mill part setup one. It's facing, that's good. It rough mills, contour mills. Let's do this. Let's just delete everything. Contour mill the outside, delete, because we know it's this pocket that's the real trouble. Contour. We'll even take these drills out. Delete, yes. Drill, delete, yes. Tap, delete, yes. My videos have been running long. See, here's the problem. See, it's defined this only up to here. It's supposed to go all the way to the top of the part. So that's some of the crash. And you can see it's rapiding down. As soon as it hits here, right? Center drill. I'm going to delete this. I'm going to simplify this part. It also, rename, delete. Tap, delete, yes. And then the whole bottom thing, let's delete that. Because we just want to, this video is just going to be the pockets. Anal, you know that. Let's take that out. So now rough. Okay, so here, this is the rest machining. Very sophisticated. This is wonderful, right? It takes a 75, a 3/4 inch, yeah, 3/4 inch end mill. And see, here's one fundamental. It's doing the bottom pocket first, then the top pocket second. So then it does a 3/8 to get what was left over that the 3/4 couldn't get into. Then it does 0.25. It does a 1/4 inch end mill to finish. That's contour, right? Doesn't worry about it, and it doesn't spend a lot of time. So obviously, rough, hit control, rough, contour. These got to be right under the face. Now we're going to do them in the right order. But it's still, I'll save you the time, it still won't simulate right. It's going to cause problems because you can tell, right? This only goes up to here. You can see rapid moves going down here. Just in case, let's generate operation plan and say regenerate, just in case. And it added everything in because we didn't take the features out. Sometimes, okay, delete, yes, let's see how smart this thing is. Delete, maybe I went about it the wrong way. Perimeter, delete, we'll fix that, another one. Mill part setup 2, yes. Recycle bin, empty, yes, passive aggressive. Generate operation plan, regenerate from the start. Okay, see, and you got to watch. Even though you're here, when you say regenerate operation plan, it hops you over to the middle tab. They're helping you, right, to confuse where you're at. See, it still did the face mill at the end. You got to wonder. So let's get back to where we were. Face mill on top. Rough. How do we call it? Rough, rest. See, they call it contour and finish. Depends what tab you're in, whether it's a finish or a contour. And there's that. So we want to take these 3, control key to go right under the face. Bam. Now this is telling us face, so that, when you run stuff down, there's not material that crashes the tool. Do this, rough. Now, this is going to be a fiasco. We're already 12 minutes into this. Watch this fiasco. We know that this is wrong, right? Because the pocket goes all the way to the top. Why did it decide to only, because of this plane? Like Dave said, he's a smart man. He knows what confuses CAM programs. So this is a feature problem, right? We haven't defined the feature. This is just, we'll use this end mill, the operations tab. Well, what end mills, rough, rest, finish, just rough. So we got to go here. And let's fix this here. There's the other thing I hate, that these are different. Changing the order here doesn't force the order up there. Or maybe that's what did force the order. I don't know. Regular and rough. Okay. So the face is fine. This is the one. Double click on it. Watch the problems I'm going to have with this, because I tried and tried. Okay, so it's saying do this loop. I want to start it higher. And some features, it says, it has 2 end conditions. They don't say start condition, end condition. 2 ends. Well, it's a slot. You're not allowed to change that. Edit feature. Okay. So now you're saying, okay, good. It's doing this. This is just what we want. We just want to start it. Instead of starting it here, we want it to go all the way and start at the top. Even though it's a start problem, it's called an end condition. All of a sudden, it changes the profile to this. I tried and tried. I couldn't get it to work. So what we have to do, after rehearsing and rehearsing, we have to erase this. Delete, yes. Regular slot. Remove, yes. Then create 2.5. Oh no, we're going to see, no. 2.5 axis feature. We don't want a slot, because I've been through this. You should see it starts cutting out here, and it gets all confused, and it probably is operator error. But boy, is this hard to work with. Okay, I thought, well, for the entities, do this and this. They'll add together. Now it gets all confused. Can't do that. You got to do something really tedious, because software is supposed to eliminate tedium when really it. And there was something else. What? Convert to loop, open chain, I think you select. How you're supposed to remember all this. See, I'm an intermittent user. I do this for prototyping. So now you same thing. You can't do the faces. That cause problems, for me at least. You got to do it very tediously. Select these. Select these. Select. It's nice that they help you with this little vector. This is very impressive. You do this, it's smart enough to do that. If you miss one, this blue goes away, because it's like, hey, it's not a close contour. And I assume we're all familiar with the grief of trying to find and fix open, broken contours. Come on, Paul. All right, we want to do this one. We're doing so. Oh, wait, now here's a real trick. See, because this one. No, we're okay. Just do this. It's another one we're going to have fun with. This one, you got to make sure you get this one, and this one. See, it's still working. I know this is pretty hard to follow. I'm sorry. Then this one, then this. I think it followed it. And here. No, it's confused. Here and here. I think that's saying, I think I've defined the edges of the pocket. And you go up here because nothing's in a convenient spot. Now it's coming down. It acts, it starts at this pocket, even though end condition 1, end condition, look at this. End condition, direction 1, end condition, direction 2. This is set to 0 because it's based on where that profile was. Except it was smart enough, because maybe I picked this first instead of picking down here. It's smart enough to put the profile unbelievably 2 end conditions instead of a start and an end. So then you say up to face, and you want to go down to this face. Bang. Perfect, huh? Sweet. Say check. Now you define that feature. It's the first thing you're going to do. You face it, then you do this. So now let's say, I learned never go up here because it'll do goofy stuff. Generate operation plan. It did. Now it jumped, it turned all blue. Panic you. That's because it jumped tabs. We were over here. And when you did generate operation, you did right click generate operation plan. It helps you by jumping over there. These are all blue because it doesn't have toolpaths. You generate the toolpaths. Bang. Now, face mill. Oh, it always does them in the wrong order. Don't know why. Always fighting. It's automatic. Automatically wrong. Okay, rough. This is the other problem I have, is hovering versus clicking. Okay, then it does rough with a 1/2 inch. Oh, the 3/4 inch end mill, it decided not to use. It's just doing a 1/2. It's doing a rough. Then the rest with a 1/4, and then the contour with a 1/4. This one, it stayed with the 3/4, the 3/8, and the 0.25. Why it decided that? That's all in the technology database and strategies and all this. Oh, and that kind of feature gets handled this kind of way. Sorry, we generated our toolpath, simulate toolpath. How are we doing? 19 minutes. Did I leave this on? Yes. Okay. Oops, we still got a crash situation here. What is it? Rough mill. Oh, I know what's doing this. Okay, this is entertaining. You'll enjoy this. And now we're done. See, because we took all that other stuff out. Now watch this. Oh, that's cute, isn't it? It gouged here, and it gouged here. I think maybe this is why they forced the goofy order of trying to do the lower pocket before it does the upper. it's got this big thing missing. There's a deterministic way why it did this, but it's pretty entertaining. Okay, here, and you go to that. We're in operations. We're in rough. See, these greens, I believe, are rapids. So it's rapiding down. Will be okay. I think it's the second one. Yes. See, this is the rest mill where it's taking the little leftover pieces that the bigger mill couldn't get. So it's rest machining, but then it decides just to bomb right through. Lots of... So when it rapids over to go do this little bit of leftover, then it rapids over here to do this little bit of... That's where it's nicking and gouging off these things. Not very smart. Good enough that they show us, though. Bless that. So, once again, middle tab, rough mill. I think you just double-click here. Yes. Then I have to open these off screen because if I close it on the screen, it goes to a non-existent monitor and I got to go hunt it. You're going to have to put up with this. Then tool, this is a tool it's using, fine. FS means feed and speed, didn't want to write it out. Roughing, this is, leave a 10,000ths of an inch allowance. The finish mill is going to clean that up. Lots of choices, I assume needed. NC, numeric control, that's what it means. It should be toolpath. What's going on is we don't go up high enough as we jump around to do those leftover corners. So clearance plane is top of feature. We want top of stock. Boy, did it take a long time to figure this out. Oh, don't say okay here. I'll be in deep doo-doo. Pull it off screen and say okay. Did you see him jump up? Now those gouges will go away. Is it too tedious showing you over and over? That's why I took about all the perimeter and all that stuff out, so it's a little quicker. Because this is what I've been doing all day. 2 days, in effect. Notice there were no crashes. But we still have stock here and stock, this stock. And now that we took those holes out, you can understand what was going on, why we had that little swoop right here. When the hole was being machined from underneath, or actually they come from above, I guess because there's a center drill would hit here, a lot of it gets cut off by the drill. And so all that was left over was this little corner here. But something was wrong, right? It's really important to find that out, okay? Get out of the simulation. Let's save it because we're in the save. Read only. Writable. Is that a writable? Saving the following files to the current version. He must have an older version. But I just wanted, because I got to convince him, like, Dave, this is the way it acts on my machine with my version. Now, we got to fix, once again, you go back to the features, a regular slot. This is our problem, right in this area, and you can see, right, these dashed lines. Is it so confused? It kind of knows that it's confused. Same thing here, dashed lines. There is a place on the, let me go back. Pick the rough, I guess. Or maybe let's try the contour. When it's doing the final finishing, contour mill. Double click on it. And boy, am I confused now. Oh no, it opened up here. See? I constantly confuse myself between these two tabs. Double click on it here. Edit feature, end condition. There was edit feature profile. Profile is offset. Maybe real time, you'll see me doing this. Profile segments. What is this? Air segment. See, I was looking and looking for this. There may be a way here to mess with it. I'm giving up. I at some point in time, go to features, irregular slot. You can delete it. Yes. Remove. Yes. And then what I had to do is go here to the, now we're doing something in the part in order to get it to machine over these open holes. And the way, this is my dream to do, the way I dreamed up to do it. I'm not saying this is the right way. I'm the newbie. All right, select that face and make a sketch there. While the face is selected, convert that face in the lines onto the sketch. Bang, there they are. While this is still happening, go select this. Where it's wrong, delete it. Come over here where it's wrong and delete it. This one's pretty easy to fix. Grab this, drag it out. When it snaps there, done. This one was a little trickier. To be safe, because we all know about laying stuff on top of one another, I erased that one. I erased that one. Then, select this, say convert. Select this little one, say convert. Select this big long one and say convert. Excellent. Then exit the sketch. Call this CAM kludge sketch. It took a long time to figure out how to fix this. All right, so we've done that. Escape so that nothing's highlighted. Now you can go into features. 26 minutes, will we make it? I don't want to go over a half hour. Irregular pocket. Okay, so then we say 2.5 axis feature. I don't like slots. I'm a pocket guy. Available sketch, CAM kludge sketch. End condition. Look at that, it's going blind, obviously. Up to face, and it's on the floor, so we got to go up to this face. There we are. See, but the important thing is we got a straight line going across there, and we got a straight line so we won't leave anything over. And I think we can just say done. And I think we can just say, generate operation plan, it thinks. It's jumped us over a tab. Say generate toolpaths. Nothing's complaining. Let's go see simulate toolpath. Make sure you've got pause on collision. And before you go to the mill, you should have all of these turned on, because you're going to want to make sure that when it's cutting the flutes, you can't cut with the smooth shank against the part. That's a no-no. A chip will get in there and ruin everything, break the tool, who knows. So we'll go real fast. And then I have another problem, as I discussed in the third impression video. Oops. Rapid collision occurring, rough mill between the tool and the stock. Oh, that bothers me, I'm telling you. Oh, maybe it did the same problem. Okay, this is the same problem. We can fix this. See this? It just seems you're constantly doing stuff over. Okay, so this rapids down and rapids there. It'll be this one. See where it goes. So we know how to fix this. We've been there before. Open this off screen. Go to NC. Instead of top of feature, top of stock. Drag it off screen because of my goofy Windows. It's Windows 7. Don't blame SolidWorks. Windows 7 they don't even approve of. Okay. Jumped up. I always go generate toolpath again. By the way, while we're here, parameters. Now it's cutting in 5. Oh, because we cut all the perimeter out. Okay. Doesn't really mean anything. And simulate toolpath. It's a race. 29 minutes. Can we do it? I think it's done. And here's the real Megillah. Okay, it didn't cut the perimeter. We took that out. It didn't cut here because that's multi-surface, whatever. We'll multi-plane. Is that it? Multi-plane machining. That's a whole separate video. But look, up here, it's all green. Just what you want. And then over here, 2957, all green. So those were the kind of, this automatic stuff, I'm sorry, it tends to put, for me, might be because I don't know how to use the program, it tends to put stuff in the wrong order. It tends to make assumptions that a machinist wouldn't make. So this is the first episode of the test part. So we'll do another one and show also that same problem I have. I can't use a 3/4 inch end mill. I can't even use a 1/2 inch. My spindle, the slowest it goes and is rated for that it won't burn up is 8,000 RPM. You usually be exceeding the surface feet per minute of the tool at that speed. You want to operate at 24,000 because that's the most power. That's where you're getting the full 2.2 kilowatts out of the thing, and you can take the chips off the fast. Now, in my Avid gantry aluminum machine, it might not be stiff enough to do that. But you should start trying to get chips off the fastest and then work your way down. Can the tool take it? No, slow it down. Okay, now will the machine take it? And then slow it down further. And that's both rotation and feed rates. And this program helps you a little, helps you a lot actually. When you change RPM, it'll automatically tell you, well, here's how many surface feet per minute you have on that tool because it knows the tool diameter. So that's it. Fun today. Hope you guys learned something. Good luck with your CAM ventures. Next time we'll go back and touch up this part a little more, but that's what I have to do. And now Dave can watch it and tell me, did it work the same way in his earlier version, or is something really crazy going on between what he's seeing in Silicon Valley and what I'm seeing here in beautiful Brandon, Florida. All right, catch you next time. Good luck with your projects. Bye now.